Now I want to explain something that is called Pascal's triangle for smaller powers. This will be helpful to find coefficients. Okay, I'll just explain it like this. Write 1 like this, then break it, then write 1 twice just below this. Now what you have to do is, now in the first row we have taken just one number. In the second row we have just taken 2 numbers. In the next row we will take 3 numbers. Try to understand that. Nth row, n numbers. How do we take the numbers? This one will come here, this one will come in the end. In the middle, add these 2 numbers. So 1 plus 1, we get 2. I hope it is clear. Then in the fourth row, so this is first row, only 1 number. Second row, only 2 numbers. Third row, we have 3 numbers. So these are 3 coefficients. I'll explain for what. Then fourth row, if I want to draw the fourth row, how should I go about it? This one will come in the beginning, this one will come in the end. Now add these 2, write it here. 1 plus 2 is 3. Add these 2 and write it here. It is 3. 1, 3, 3, 1. Now what are these numbers? These are actually the coefficients. Look at it closely. This is the coefficient in x plus y to the power 0. These are the coefficients in x plus y to the power 1. These are the coefficients in x plus y to the power 2. If you are not able to understand, expand it. You will get it. X square plus 2xy plus y square. Look at the coefficients 1, 2 and 1. Can you see that? 1, 2 and 1. So if I have x plus y whole cube, right? These will be the coefficients. We have already explained the variable powers, right? This 1 will come with x cube. This 3 will come with x to the power x to the power 2, y to the power 1. This 3 will come with x to the power 1, y to the power 2. And this 1 will come with y to the power 3, right? If I want to write x plus y to the power 4, how do I go about it? 4 will be in the 5th row, right? So for 5th row, how do we take? This 1 will come here, this one will come here. Add these 2, you get 4. Add these 2, you get 6. Add these 2, you get 4. So coefficients are 1, 4, 6, 4, 1. Remember, if the power is 4, there will be 5 terms. And the terms will be, with respect to the powers of variables, the terms will be x to the power 4, x to the power 3, y to the power 1, x to the power 2, y to the power 2, x to the power 1, y to the power 3, and y to the power 4. And their coefficients, first coefficient is 1, second coefficient is 4, third coefficient is 6, fourth coefficient is 4, and fifth coefficient is 1. I hope it is clear. If I want to write x plus y to the power 5, then can I write it directly? This 1 into x to the power 5 plus 1 plus 4, that is 5, x to the power 4, y to the power 1. 4 plus 6, that is 10, x to the power 3, y to the power 2. 6 plus 4, that is 10, x to the power 2, y to the power 3. 4 plus 1, that is 5, x to the power 1, y to the power 4. And 1, y to the power 5. So this way you can go on doing. So obviously, as I said, this will be really useful for smaller powers, and you have to go in sequence. Okay, otherwise you already know the general expression. All right, so I'll just take one more example using NCR. So if I want to find, let's say, if the question says find 10th term, or wait a second, 10th term, 10th term in the expansion of x plus y, or let's complicate a little bit more, 2x plus 5y to the power 13. So if I want 10th term, remember r plus 1 is 10. R plus 1 is 10. So r is equal to 9. So how do we put in the general expression? We have already done that. 10th term will be straight away equal to 13c9 into 2x to the power 13 minus 9, that is 4, 5y to the power 9. Now, we know NCR is equal to NCn minus R. That is entirely different thing that you must have done in PNC chapter. So I'm not going into the details of that. Okay. So 13c9 will be 13c4 as far as the value is concerned. 2 to the power 4, 5 to the power 9 into x to the power 4, y to the power 9. So this is the variable part and this is the coefficient. So if the question is coefficient of 10th term in this expansion, then the answer would be this value, whatever you get, 13c4 into 2 to the power 4, let's say, okay, let me check if it is, yeah, 5 to the power 9 is 31250000. Yeah, I'm just writing it. This is the answer. This is the answer. If you can simplify, great. All right. So I think this covers, till now we have covered the expansion of, till now we have covered the definition of binomial expression. Okay. We have seen the expansion of simple expressions, right? And we have seen the general term, right? Or a term with respect to the position, how to identify that. We have seen and understood, I hope so, how to calculate the coefficient of a particular term based on the position and the powers of variable in a term. Powers of variable in a term. Okay. In this segment, I'll also show if there is only one variable, then how does the question look like? Okay. Say for example, if I have 1 plus x to the power n, can you see that 1 plus x to the power n? Now the first variable is 1, right? If you expand it, it is nc0 into 1 to the power n plus nc1 into 1 to the power n minus 1 x to the power 1 plus nc2 into 1 to the power n minus 2 x to the power 2 and goes on up to ncn 1 to the power 0 x to the power n. Can I simplify and I say it is nc0 plus nc1x plus nc2x square, and I'm sure this you would have seen many times, x cube plus up to ncn x to the power n. This is 1 plus x to the power n, right? Here I'll again introduce the minus sign. If I have 1 minus x to the power n, what will happen? Instead of x, wherever you see x, put minus x. So what will happen? All the odd powered position terms will become negative. All the even powered position terms will remain positive. So 1 minus x to the power n will become, it's like saying in place of x, replace minus x. So nc0. Now nc1 into minus x. Okay, let me take one more step once and for all. nc2 x square की जगह we will have minus x square plus nc3 in place of x we have minus x cube plus up to ncn minus x to the power n. So basically 1 minus x to the power n, it becomes nc0 minus nc1x plus nc2x square minus nc3x cube and so on. And the last one, because we don't know, we'll simply say ncn minus 1 to the power n x to the power n. That's it. You know, you can reverse the direction, x plus 1 to the power n. It will become nc0 x to the power n, nc1 x to the power n minus 1, nc2 x to the power n minus 2. So these are just different ways of writing. Don't spend too much time on deciphering everything here. This so this will become nc0 x to the power n minus nc1 x to the power n minus 1 plus nc2 x to the power n minus 2 and so on. And the last one will be ncn. The last term will be, you have to be a little careful there for the sign, minus 1 to the power n, right? So that's how you can see all the expansion. These are all binomial expansions, right? First we did it for 2 variables. Here we did it for 1 variable.